A generator is a lot like a motor, at least in the parts that constitute the generator. So there's a armature or loop of wire. There's some external magnetic field. There's an axle upon which the armature is mounted. The only difference here is we're not going to send an electric current into the loop and then have the resulting rotation. We're going to make it rotate, maybe by putting a handle on it and then cranking that with your hand and rotating this at some steady angular velocity omega. So instead of putting electricity in to get motion out, we're going to put motion in to get electricity output. So that output voltage is governed by Faraday's law, equal to negative the number of loops. So I guess we could take this loop of wire and go 1, 2, 3, 4, 5, 6, wind it around and around. And in fact, this problem says there's 150 total windings, so that's the n in the equation, and times d phi dt. Or in other words, the EMF is equal to negative n times d dt of the dot product of magnetic field and area, which gives us BA cosine theta. So negative n d dt of BA cosine theta. So in this problem, the magnetic field strength is given as 0.02 Tesla. So the spacing between these magnets isn't going to change. They're not going to be replaced with stronger or weaker magnets. So we have a steady value of magnetic field. And let's see, the diameter of the loop. Okay, so it's a circular armature. I had drawn it rectangular, but then I changed my mind and drew a circle. And the diameter is 30 centimeters, so the radius would be 15 centimeter, or if you prefer, 0.15 meter. So the area isn't going to change, area being pi r squared. So if the magnetic field strength is constant and the area is constant, then we can say the induced voltage for our generator is negative nBA times d dt of cosine theta. Well, if something spins at a steady rate, then we can say that its angular displacement is just that steady rate of radians per second multiplied by some number of seconds. So what we really have here is d dt of cosine of omega t. So the derivative of cosine gives us negative sine. So we end up with EMF equals negative nBA times negative omega sine omega t. So the negatives cancel out, and we have EMF is equal to omega nBA sine omega t. Let's read this question one more time. Okay, so the generator has a circular armature. We're given the diameter, so from that we know radius, the number of windings. Here we go. It spins at 500 RPM, and then we're asked, what's the induced EMF? I'm going to assume this means what's the maximum value of the induced EMF. If we made a graph for the induced EMF versus time, since all of these terms are constant, we're really just making a graph of sine. So the EMF varies. So if the question says what's the EMF, it could be anything as long as it's no greater than that value and no less than this value. So let's figure out the max and min value. We'll call it Emax and Emin. So the maximum value is just omega nBA. So we were given 500 RPM, or in other words, 500 revolutions per minute. We need to change that into radians per second. So there are 2 pi radians in every 1 revolution, and then there's 60 seconds for every minute. So if we cancel out, we can convert to radians per second. So grab a calculator, see what you get when you multiply 500 times 2 times pi divided by 60. You get about 52.36 radian per second. So our maximum EMF is 52.36 radian per second times 150 loops. Yes, 150. Magnetic field, 0.02 Tesla. And then our area is pi r squared, so pi times 0.15 meter squared. Okay, so we have square meters and Teslas, that's Webers, and then we've got radians per second, but we can ignore radians, so our units are going to be Weber per second, but a Weber per second is a volt. So if you multiply all this through, what do you get? And I got a final result of about 11.1 volts. Double check and see if you get the same value.